In this video, we'll look at an overview of working with arrays in Genero. What is an array? An array is a series of objects, all of which are the same size and type. Each object in an array is called an array element. You could have an array defined as any supported data type or record, but not another array. For example, you might have an array of integers or an array of characters, or commonly in Genero, an array of records from a database table. Array elements can be accessed via an index and are continuous from a logical point of view. So as you see here, you can identify an element in the array by referencing the logical element number. For a record, you'd reference the element number and the column in the record. Arrays can have 1, 2, or 3 dimensions. One way to visualize an array is to think of the popular puzzle Rubik's Cube. A single row or column would be a one-dimensional array. A one-dimensional array is sometimes called a vector, and here, this particular column would have 3 elements. One face of the cube would be considered a two-dimensional array or a matrix. It has 9 elements, or 3 times 3. The cube itself is a 3-dimensional array, and it has 27 elements if we're looking at each of the cells here in the cube representing one element in the array. In Genero, your program establishes a connection with a database, and as you learned in the Using Cursors video, you can set up a cursor to manage a result set of rows. Data from the result set can then be used to fill the array with data. Your program array data is then displayed to your screen array, either a table container or a tree view container. Depending on whether you have begun a display array or an input array, the container will allow the user to browse and/or modify the data shown. Let's take a look at defining the program array. There are 2 ways to define a program array. The legacy way is to define it as a static object with a set number of elements. So here you can see we're defining store R with 5 elements as an array of record consisting of the store num, store name, and phone columns. Static arrays are explicitly sized, as you see here, and all the elements are initialized. So you can imagine that it uses quite a bit of memory and resources if you have a large-sized array defined. You can also get array out of bounds errors if you exceed the maximum number of elements in the array yet try to fill it with yet another element. And the maximum size allowed with a static array is 65,535 elements. A better and recommended way of defining an array is dynamically. You can see in the syntax here, you change from explicitly setting the number of elements to specifying that it's dynamic. So we're defining store R as a dynamic array of record. It's variable size, so there's no theoretical size limit. The elements are allocated automatically as instructed, so they're not predefined up front. So for example, when you fill the array with data from a result set, the elements will increment automatically. Now in this code here, we see the loading of an array. To fill the array with data, typically from a result set, you'll use a for each loop. So you can see in this for each loop, we're going to take each of the records that are in the cursor set into our record, and then we're going to append an element and let that new element equal the value in our store record. So in this code, the append element method appends a new element to the dynamic array. Then the last fetched record is assigned to the newly created element at the end of the array. All members of the record are copied respectively to the members of the new array element. This continues until the result set is exhausted, then the cursor is closed and the for each loop is ended. So for example, if we defined the store array and we declared a cursor, the first thing here you saw was it's being cleared, and then in our for each loop we're going to go ahead and fill the array. So the elements, if there were 3 rows in the result set, our first element in the store array would be this one, 701 Dan Sports, with the phone number. And then the next one would be in position 2, and the next one would be in position 3. This code here at the top is using the getLength method to identify the size of the array, thus giving us the number, or the argument that we need here, the number for the position in the array that we are passing those new values to. Now in this code you can see that we then have a display array instruction, and the display array dialog allows you to let users browse the list of records using an array as the data buffer. So in display array here we're mapping the array to our table container that we have in our form. You can also use input array. An input array dialog supports data entry into a screen array and stores the entered data in the program array. So the user is able to move around in the table container or tree view container and edit, delete the existing rows, insert new rows, and move inside the list of records. Now in this section on arrays, you'll find some additional videos on both the display array instruction and the input array instruction.